Hello, this is David Shreeve, Algebra 2 instructor with Florida Virtual School. We're going to continue with this same quadratic function, but instead of finding the axis of symmetry and the coordinates of the vertex, we're going to go ahead and find the zeros here. So when we talk about solving quadratics, we can use several methods. We can use factoring, graphing, completing the square, quadratic formula. You'll notice in this case, I'm not going to find any factors of -7 that add up to -4, this middle term. So factoring's out of the question here. Also, we are going to learn about finding the discriminant. When you find the discriminant in this particular function, you'll recognize that you're going to have irrational roots. In other words, if we graph this, we might get a decimal approximation of the zeros, but we're not going to find the exact zeros as far as a value in simplest radical form that is more accurate than that decimal estimation. So that leaves us with quadratic formula and completing the square for this particular function, and we're going to go ahead and find the zeros of this function using both methods. So anytime I'm going to use the quadratic formula, I like to have that quadratic formula written down. That's -b plus or minus b squared minus 4ac, and that is all over 2a. So obviously I need my a, b, and c values here. Remember, a is the coefficient of my x squared term. B is the coefficient of the x term, so, and C is my constant. So I've identified my A, my B, and my C. From this point, we can go ahead and plug the A, B, and C into the formula, and then just all we're doing is simplifying from that point. So always plug my values in parentheses. It's pretty important. You'll run into some issues with the sign here if you don't, because a -4 is going to turn into a +4 for us here in a moment. Okay, so b squared. Again, the parentheses are important. Alright, so I've got all my values plugged in. At this point, we're just going to simplify. So a -4 is a +4, plus or minus the square root of -4 squared is +16. That's why those parentheses are important there. Minus, 4 times 1 is 4, times -7 is -28. Once again, we have to be careful with our signs. 2 times 1 in the denominator here is just going to be 2. This is going to turn into 16 plus 28. And we probably could have done that in one step, but I like to show all of my work. That way, if I do make an error, it's pretty easy for me to go back and look through my steps since I've shown every step there. Alright, so 16 plus 28 is 44. Now, the square root of 44, we can simplify that a bit. So it's important to remember our work we did from the unit on simplifying radicals. 44, I'm just going to write the square root of 44. That's the same as the square root of 4 times 11. In other words, 4 times 11 equals 44. So I'm just writing things in equivalent form here, which is also written as square root of 4 times the square root of 11. And obviously I can simplify the square root of 4, that's 2. So 4 plus or minus 2 square root of 11 over 2. Now, what's interesting here, we can simplify this even more. you'll notice that you have a 2 down here. This 2 is, of course, divisible by 2, so 2 divided by 2 is 1. And the 4 is also divisible by 2. 4 divided by 2 is 2. So you're just going to end up here with 2 plus or minus the square root of 11. And that's using the quadratic formula. Now let's go ahead and see what we get when we complete the square. Keep in mind the zeros for these functions will be the same regardless of the method you use. So if you work it out with the quadratic formula and you get a much different answer than when you were completing the square, then there may be an error in your calculations. Alright, so this is f of x equals this function. I'm just going to set the function equal to 0 for the purposes of completing the square. So we'll have x squared minus 4x. I'm going to add a 7 to each side. That equals 7. You'll notice I left a good portion of space here. Now what we're going to do is we're going to create a perfect square trinomial on the left-hand side. So this is where those special patterns in factoring back from Unit 3 are important. We do have to be very proficient with our factoring for many mathematical concepts. So what I'm going to do here in steps, I'm going to take my coefficient of the x term, in this case it's -4, and I'm going to cut it in half. So just multiply that by 1/2 or 0.5 or divide it by 2. What you're going to get is -2. I'm going to take that value and I'm going to square it. When I square -2, I get 4. So 4 is the value that I'm going to add to each side. And here's why. I've created a perfect square trinomial now over here on the left-hand side. X squared minus 4x plus 4 factors to x minus 2 times x minus 2. Well, we can write that as x minus 2 squared. Don't forget we added a 4 over here, so 7 plus 4 is 11. Well, that's still not quite in the form I need. I need this 11 over here on the left-hand side. But for the purposes of solving by completing the square, I don't really necessarily need to take the time to put this into general form. Alright, I want to go ahead and solve it from this point. So what I'm going to do, I need to get rid of this exponent up here because I want this x by itself. That's what I'm going to be solving for. So if I have a term that's squared and I want to get rid of that exponent, I can simply take the square root of each side. The square root of the quantity x minus 2 squared is simply x minus 2. Alright, equals, when we take the square root, remember we need to consider the positive and the negative. So x minus 2 equals positive or negative square root of 11. To solve from here, we'll simply add 2 to each side. So x equals, I could say plus or minus square root of 11 plus 2, but I'm just going to write my 2 over here on the left. And that's my final answer to get the zeros. You'll notice here we do end up with the same value regardless of the method that we use. Hope this helps.